equilibrium a little bit. This last section of the entire unit, we're going to be talking about your equilibrium constant. And what your equilibrium constant, your KEQ, what that allows you to do is determine whether your equilibrium, once you get to equilibrium, whether it's going to lie more on the product side, meaning you have a higher concentration of products or a higher concentration of reactants. Alright, so let's look at an example. We'll look at an example in a second. I want to show you the equation. It really shouldn't be that overwhelming. All you do, your equilibrium constant equals your concentration of your first product, doesn't matter which one you choose, raised to its coefficient, times, if you have another product, that concentration raised to its coefficient, divided by the reactant concentration raised to its coefficient, little a, times the concentration of big B raised to its coefficient, little b. Now, I think that's might seem kind of complicated, so instead, why don't we try an example problem? So, the problem that's given to you, it gives you this formula right here, and it gives you the concentrations. So, all that you're going to need to do is fill in the work. So, remember, to find KEQ, you need to take the concentration of your products. And so remember, this is your product, NO2, and the concentration of NO2 that's given to you is 0.571. And you guys don't even have to put it in brackets. Just know the brackets represent your concentration. So concentration, there you go. Now, I need to raise it to its coefficient. The coefficient of NO2, if I look at my reaction, well, that's a 2. So I'm going to square this. And I'm going to divide that. Notice there's nothing else to multiply by because I've only got one product. That's fine. If I had another one plus another one, then I would multiply that there. But right now I don't have another one, so I'm good. Now I'm going to do my reactants. I've got N2O4, and its concentration is 1.5 times 10 to the third. Sorry, negative third, not third. But if you notice, there isn't a coefficient there, so we assume it's a 1, so that's going to be raised to the 1, which I don't actually have to write. So now all I have to do is the simple math. So I take 0.571 and I square that. All right, and I get 0.326, and I'm going to take 0.326. And guys, you should have your calculators out, so I'll wait for a sec. So everyone pull out your calculators. I need you to do 0.571 squared. And then divide, and remember guys, when you divide, be careful. If you're going to be dividing by this entire quantity, make sure you're using parentheses, or else what your calculator will do is divide by this and then multiply the whole thing by 10 to the negative third. So you can use parentheses, or you can do 1.5 e negative 3. Either one's fine with me, but make sure you get the answer that I get. So I'm going to use parentheses, divide by 1.5 times 10 raised to the negative third, and I get 217.36. Okay. If I did the incorrect division, right, without the parentheses, then I would have gotten 2.17 times 10 to the negative fourth, which is incorrect. Okay, I think this is going to be your most favorite part of this section. You don't need units. This is your final answer. But what your KEQ is telling you guys, since this is a lot larger than 1, if you notice, this is products over reactants. So if your answer is much bigger than 1, in this case it's 217, that tells us that our products, there's a much greater concentration of products than reactants. So what we say, the expression we have is that our products are favored. Okay? Now, that doesn't mean we're not at equilibrium. It just means that that concentration of product is a lot higher than reactants. Products are favored. But you're still having that same rate of movement in the right-hand direction, in the forward reaction, and the reverse reaction. All right? So what you're going to do now is you're going to work on practice problems, but here's the thing that I want to make sure you guys are comfortable with. Okay, let's say I gave you a different problem. Okay, we're going to use the same numbers from this problem, but let's say instead I said, okay, your KEQ in this problem is 217.36. Oops. Now, your KEQ is 217.36, and I know my concentration of N2O4, but I haven't given you the concentration of NO2, so let's ignore that. Now, I could ask, and I will ask in the practice you're about to do, what's the concentration of NO2? Now, I know I can use the same formula again, guys, but I'm just going to plug in different numbers. Since I know KEQ, I'm going to plug that in that equation right there. So 217.36 equals, now I don't know the concentration of my product. So I'm going to write in brackets concentration of NO2. Now that needs to be squared because I have a 2 coefficient out front. Remember, you square. So I'm going to put a 2 there. Awesome. All over, I know the concentration of my reactant, which is 1.5 times 10 to the negative third. So here's now what you need to do. I'm going to take this, put it over 1. I'm going to cross multiply. So 1.5 times 10 to the negative third times, times 217, and then NO2 squared. So what I get is NO2 squared equals, now I need to take 217.36 and multiply by 1.5 times 10 to the negative third. And guys, check me on this, please. So have your calculators out, see what you get. Are you guys getting 0.326? I'm hoping. Okay, double check your math if you're not. Okay, now notice this is NO2 squared. So the only way I can get rid of a square is take the square root of it. So guys, this is algebra intensive. It's not really concept intensive. So if you're having issues with squares, all of the roots, you need to come into me or shoot me an email and I can post a video explaining the math of it. But what you're going to do in your calculator, take the square root of 0.326, and if you can't figure out how to do that, ask a classmate. And what you should get is that the concentration is 0.57. Remember, concentration in this problem, the units are molar, so it's 0.57 molar. And notice it's actually 0.571 because I got 0.57096. That's the same as what was here. Okay, so that works out perfectly. So you guys know how to calculate the KEQ, or if I give you the KEQ and the concentration, you guys can then go and calculate the concentration. Remember, guys, that this problem doesn't get that much more complicated if I add another product. Let's say I'm going to add product B. All you're going to do, let's say it's 2B, why not? Then this is just going to be times B squared, whatever value that is. You just add it in there. Well, not actually add, you multiply it in there, right? And so it would be 0.571 squared times whatever value B is, that squared, and then divide by 1.5 times 10 to the negative third. That'll be your KEQ. So don't freak out about the math, guys. The main concept here is that your KEQ equals your product concentration raised to its coefficient times however many products you have, all over the reactant concentration raised to its coefficient. The last thing to remember, if your KEQ is less than 1, so this one, if your KEQ, now you need to rewrite this, if your KEQ is less than 1, what that tells you is that R is greater than P, right? R is greater than P, and therefore your reactants are favored, so R favored. And then remember, if your KEQ is greater than 1, and this is failing to write right now, if it's greater than 1, then your products are favored. Okay, and that's all there is to it, guys. If you want to shoot me an email, I can put up another video explanation of this, but what I'm going to have you do right now is finish the rest of page 7, and then your sub is going to give you a Unit 14 review. All right, that's it.